see that the two functions that are defined, the domain is for all real numbers, f of x is a quadratic, and g of x is a linear function. We want to find the range of f. Well, there's two different ways we could do this. The first way is we could rewrite this function in a vertex form. So this would be something like this. I'm going to pull out the -2 because I think it'll make my life easier. And now I'd have to complete the square. And then I would just FOIL out everything. So this is +8. So if you know how to do this, then this can be quite nice. Because at this point, you've got your max right here, where your vertex is given to you. Oh, let me try. The vertex is 2, 1. And because this has a negative lead coefficient, this would be your max. And in this case, the range will be from 1 to -infinity, or from -infinity to 1. Now, if you don't know how to complete the square at this point, now's not a good time to bother learning. Actually, it's not a bad time. But if you don't want to do this, a second way of solving this would be, this is just a second method, I can find the derivative. So let me specify this second method. And my derivative will be -4x plus 8. Now I can find when this will be equal. So what I'm doing here is I'm finding the max. And this is true for 4x equals 8, x equals 2. So at x equals 2, f prime of x will have a min or a max. Because I know it's a quadratic with a negative coefficient, it's going to be the max. So now I can just plug in for f of 2, which will be -2 times 4 plus 8 times 2 minus 7 minus 8 plus 16 minus 7, which is equal to 1, which is very much the same thing. So because this is my max here, right, my range, again, would be from -infinity to 1. If you wanted to double check, if you somehow didn't remember lead coefficients, you could do a second derivative test and check that holds. Now we're going to move on to B. G of f of x is greater than 0 for all x. Let's just quickly do g of f of x. G of f of x is going to be -2 f of x plus k. That's -2 minus 2x squared plus 8x minus 7 plus k, which is equal to 4x squared minus 16x plus 14 plus k. Well, and at this point, it would be easiest if we could factor. So again, two separate methods. The first one is if we can complete the square, then what we'll get is a format where we can see all the values of k, where we just want the y value of the vertex to be greater than 0. So here we have 4x minus 2 squared plus 16 plus 14 plus k. Is that right? Let me just check I'm not missing anything here. Minus 2x squared minus 8x plus 17 minus 7, sorry. So that's 4x squared, we're good. Minus 16x plus 14, and k is unaffected. Okay. in which case now we would get 4 x minus 2 squared plus 30 plus k. And here we just need 30 plus k to be greater than 0. So k just needs to be greater than 30. All right. Well, oh, sorry. So be greater than minus 30 in this case. Okay. Let's check this with a second method. Second method. Now, a second method would be to take this quadratic right here and realize that if it's greater than 0 for all x, it has no real roots. And if it has no real roots, it means that the discriminant must be less than 0. In which case, this means so the discriminant is b squared minus 4ac is less than 0, and b squared is minus 16 squared minus 4. Where this is now c. 4 times 4 times 14 plus k is less than 0. So this is 16 squared minus 16 times 14 plus k is less than 0. Let me make a little space over here. I can simplify this by just factoring out 16. And here you're just going to pick whatever seems easiest. I'm doing this because it allows for fewer calculations. 16 minus 14 is 2. Minus k. It's got to be less than 0. 32 minus 16k is less than 0. 32 is less than 16k. K should be greater than 2. Uh-oh. I'm not getting the same answer. Ah, yes, okay, I see. I made a mistake over here. This, in my mind, did I make this mistake more than once? No, because it was negative over here. Right, okay, so this is what I remembered. I failed to complete the square appropriately. There we go. Comme quoi, ça fait du bien de vérifier. So this here should be a negative. This here should be a negative. So this then should be minus 2. Okay, and so this is what I should have found. K minus 2 greater than 0. K greater than 2. Okay, and now we find the same answer twice. Well, if you can complete the square better than I just did, then quite comfortably you should use this first method. I think it's easier, less computationally intense. If not, then the second method works just fine. And I think that resolves what we need to find, the set of possible values of k. We've done that.